In this session, we're going to use the limit definition of derivative to find the derivative of absolute value of x. So, we're looking for the derivative with respect to x of the absolute value of x. So, the limit definition of a derivative is the limit as delta x approaches 0 of f of x plus delta x. So it's the absolute value of x plus delta x minus f of x, which is absolute value of x, all over delta x. Now we have an issue here because we have a delta x in the denominator, so we can't evaluate this limit directly, but we perhaps can manipulate in some way. Let's use a conjugate of this. So what we're going to do is we're going to multiply the numerator and denominator by x plus delta x plus the absolute value of x over the same thing. Okay, so we're going to multiply this thing out, and of course as we go down, this limit is going to be progressed down. So it's the absolute value of x plus delta x times the absolute value of x plus delta x is simply the absolute value of x plus delta x squared. Absolute value of x plus delta x plus absolute value of x minus that product. Those two cancel out. And then we're left with minus absolute value of x squared. This times this. And that's all over this product here. So that's delta x times absolute value of x plus delta x plus absolute value of x. Now, in this situation, when we have the absolute value of x plus delta x squared, the need for the absolute values disappears. And what we're left with is simply x plus delta x squared. That's a 2. And the same thing with this, minus x squared. And that's all over that quantity. So that's delta x times the absolute value of x plus delta x plus absolute value of x. Okay, so now what we're going to do is we're going to expand this binomial in the numerator. So what we have here is we have x squared, this times 2 plus 2x delta x plus this squared plus delta x squared minus our x squared. And that's all over this quantity, so that's delta x times the absolute value of x plus delta x plus absolute value of x. Okay, now it does in fact look like we have a cancellation here. We have this x squared and that x squared go away, and it looks like we actually have another one here. We have this delta x This term and this term both have delta x's in them. So let's go ahead and get rid of that, and one of those two. So now let's rewrite and simplify. So we have 2x, so this 2x comes down. We have a delta x in the numerator. And what's left in the denominator is this quantity. So we have the absolute value of x plus delta x plus absolute value of x. Okay. So let's continue this limit all the way down here, and we're actually going to take the limit right now. So limit as delta x approaches 0 of this quantity, this delta x goes to 0, and this delta x goes to 0. So we're left with 2x over the absolute value of x plus the absolute value of x. Again, when we took the limit here, we had this delta x going to 0, this delta x going to 0. Actually, that's supposed to be an absolute value there. No, it's not. And so we have the absolute value of x plus the absolute value of x left. Okay, so now let's bring this up to the top here so that we can do some more simplification. So what we have now is 2x over 2 times the absolute value of x. And don't want to have an absolute value in the denominator just because it's against convention. But here we have a cancellation for the 2's. So we have x over absolute value of x. And let's do the absolute value of equivalent of a rationalization of the denominator. Let's multiply the numerator and the denominator by the absolute value of x. So here we have x absolute value of x over, well, this is the absolute value of x squared, and as we learned earlier, that's x over the absolute value of x over x squared. That x goes away, that x goes away, and what we're left with finally is absolute value of x over x. So the derivative with respect to x of the absolute value of x is the absolute value of x over x. And this is one of the primary reasons why this function, this derivative function, has a problem. As you can tell, the limit of this function from the left is going to be different from the right at x equals 0, and that's one of the reasons why this function has no derivative at x equals 0. Because if you look at the graph of this function, very, very roughly, of course, we see a sharp turn. And that's the reason why the derivative of a function with a sharp turn is non-differentiable. Well, I hope that helped, and I will see you next time.